In the ISLM model, first we will draw the IS curve, which is the relationship between GDP and interest rate, so that saving is equal to investment in an economy. The saving and investment equality is capturing the goods market equilibrium. If you recall from the income expenditure model, we had said that the equilibrium income can be characterized through different ways. The first is that at the equilibrium level of income, planned expenditure is equal to total income, which also meant that actual investment is equal to planned investment. In other words, there is no unwanted inventory accumulation or inventory depletion. And also at the equilibrium income, saving and investment are in equilibrium. In the ISLM model, first we will derive the IS curve, and the IS curve is derived while satisfying the condition that the goods market is in equilibrium. The goods market equilibrium is characterized in three alternate ways. First, when the total income is equal to planned expenditure, the economy is in equilibrium. And why we say it is the goods market equilibrium? Because we are not considering money in our analysis. We are purely considering the production side. And the goods market equilibrium, where total income is equal to planned expenditure, was also depicting the equilibrium between saving and investment. This we have discussed in session 8 when we discussed the income expenditure model. Now, satisfying the goods market equilibrium, we will find out what are the consistent combinations of GDP and interest rate that will prevail in an economy. Let us start with the goods market equilibrium, where I have income here, and here I have the planned expenditure are here. Okay, and the 45-degree line, which tells me the equality of income and planned expenditure. And suppose initially the C plus I plus G was at this level, which was giving us a income level of Y1. Now we are saying that investment, we know, is a function of interest rate but negatively, and that means investment is a function of R negatively. By the way, this F and this F are not the same. Here we are saying investment is an inverse function of interest rate, whereas this F, which is actually the functional form I is equal to I0 minus FR, here F represents the sensitivity of investment to a change in interest rate. Okay, so suppose this corresponded to when interest rates were R1. Okay, that means investment was I1 when interest rate was R1, and that was giving me the income level of Y1. So I am just plotting this is R1 and some number, whereas the equilibrium, if you see, if I join, if I want to present, okay, the equilibrium income that is consistent with interest rate R1, I get point, this point, let it be point A. Okay, now suppose the interest rate goes down in the economy to R2, so R becomes R2, okay, and R2 is less than R1, which implies the investment consistent with R2 interest rate I2 will be greater than the investment consistent with interest rate R1. So my new aggregate expenditure line corresponding to a aggregate expenditure of C plus I2 plus G whereas this corresponds to interest rate R2. I will get what my I will get a new equilibrium GDP. Okay, and this equilibrium GDP is y2. This was y1, this is y2, and this y2 is corresponding to a interest rate of R2. So I get point B. If I join point A and B, I get what is known as my IS curve, and this IS curve is depicting different combinations of interest rate and GDP so that the goods market is in equilibrium. Now, goods market equilibrium also meant that saving and investment are in equilibrium. Now, I can explicitly show the uh, how different points on the IS curve are satisfying the condition of saving and investment equilibrium if I bring in the loanable fund theory into my analysis. And in the loanable fund theory, interest rates are decided by the equality between saving and investment, or when saving and investment are in equilibrium, the interest rate will be in equilibrium. And this fact we can capture through I am plotting my interest rate here and saving and investment on the x-axis. Now if you see, I cannot, because the IS curve is a relationship between interest rate and GDP. Now GDP, which is y, is not finding a place in either on the x-axis or on the y-axis. So I am taking y from outside the model, or let y be given from outside, and this is my y. And here I am representing this. Here I will represent interest rate. Okay, so here I will represent different combinations of interest rate and GDP so that saving and investment equality will be maintained. Please remember to the functional forms for savings. Savings was a function of income, which is positively related, and investment is a function of interest rate, negatively related. Now my investment function is downward sloping. Okay, IR negative, because this, if you recall, it was I was equal to I0 minus FR. Okay, so let initially income level was Y1. Okay, income level was Y1, and that gave rise to a national savings of the level S1. Okay, so I got, when y1 was the income, savings was s1. Now savings depends on income, but here on the y-axis I have interest rate. So savings is a number which is decided from outside, outside as far as saving, investment and interest rate is concerned. So I am getting, this is my s1. So I will get what? My equilibrium interest rate, where saving and investment are in equilibrium, is given by, say, R1. So R1 and Y1 is one combination where saving and investment equilibrium is achieved. Now suppose income level in the economy goes to Y2. Now that will lead to a savings of S2, and because savings are a positive function of income, in other words, when income rises, savings rises. So it must be that S2 is greater than S1, because Y2 is greater than Y1. Okay, so S2 I can represent as this, a higher number than S1, and now S2 and I are at equilibrium at the interest rate when is R2. So if I plot R2 and Y2, I will get another combination of interest rate and GDP, so that saving and investment again are in equilibrium. If I join the two, I get the IS curve. Now in this case, you are able to see that we have derived the IS curve so that saving and investment equilibrium is explicitly achieved. Okay, this is called the loanable funds model. Okay, the loanable funds model. So we have derived the IS curve using two different ways. One is the goods market equilibrium and another through the loanable funds model. There is a third way to determine the IS curve where the saving and investment equilibrium will be depicted more explicitly, and let us try to do that. And we will use a four quadrant diagram. The four quadrant diagram, let us draw four quadrants. Okay, and suppose here this is my fourth quadrant. Here in the first quadrant I am plotting the investment function, and in the second quadrant I am drawing a 45-degree line where investment is on the x-axis and savings are on the y-axis, and I am plotting the savings function here. This is the savings function, which is a function of income. Okay, and here I will plot r and y. Okay, so what is happening, and please remember, what is the savings function? Savings function is nothing but s is equal to y minus c, and we know c is c0 plus by. Okay, so this gives me minus c0 plus 1 minus by. Okay, so s is equal to so here I can write is equal to s. So this is the equation of a straight line. This is the savings function with a negative intercept minus c0 and a slope of 1 minus b. Okay, so my investment function I know is inversely related to r, and now let us consider that the interest rate in the economy was R1, which gave rise to an investment level of I1, and at investment level I1, what would be the level of savings so that saving and investment are in equilibrium? That is S1. Here you see the equality between saving and investment. Now we want to find out that what is the level of income which would have generated this level of savings, and this is given by the savings function, and it is coming to be say y1. So what I will do, I will plot r1 from here, and I will take y1 from here. So I get one combination of r and y. This is r1, so that the saving and investment are in equilibrium. Now suppose the interest rate drops to R2. If interest rate drops to R2, this will lead to a higher level of investment I2. Now this higher level of investment would require savings also to be at a higher level, say S2, so as to bring the equilibrium between saving and investment, and this higher level of savings would correspond to or what level of income would have given rise to this higher level of saving? A higher level of income, which is y2, and this is given from the savings function. Savings function is telling me how savings are related to different levels of income. So I get another combination of interest rate and GDP, but in this case, when the interest rate fell, we found investment increased, and so as to bring the equilibrium between saving and investment, savings must now go to a higher level, and that is S2. Now when savings are S2, the corresponding income level which would have generated this savings is Y2. So I'm plotting R2 and Y2 as another point, and when I join these 2 points I get my IS curve. Okay, so we have derived the IS curve which is showing different combinations of interest rate and GDP so that saving and investment are in equilibrium. Now we have derived the IS curve using 3 alternate methods. We can derive the IS curve through a fourth method, which is the easiest one, and that is called the algebraic method. Let us derive the IS curve using the algebraic method. The algebraic method the algebraic method is taking note of the functional form for consumption, which is C0 plus By, and for investment, which is I0 minus F into R, and my goods market equilibrium condition is Y is equal to C plus I plus G. And when I put the values for C0 plus By plus I0 minus FR, and let G be at G0. So C0, I0 and G0, these are constants, and let me take all the constants at one place, and this will give me By minus F into R, which has given me, let C0, I0 and G0 be take, because these are constants, for notational convenience I am representing it as A, which is a constant. So Y is equal to A plus By minus FR, which other words means FR, I am bringing FR to this side, is A plus By minus Y, which implies F into R is equal to A minus 1 minus B into Y, which otherwise tells me R is equal to A by F minus 1 minus B by F into Y. If you note, this is equation 1. This equation 1 is a equation of a straight line in the slope and intercept format of Y is equal to mx plus c, where c is A by f and m is 1 minus b by f and x is y, and y is equal to r. And if I plot this, how this would look like? This would look like this an equation where r is on the y-axis and y is in the x-axis, and this intercept is known as A by F, or is equal to C0 plus I0 plus G0 by F, and the slope is 1 minus B by F. Okay, and what is C0? C0 is nothing but C0 captures everything other than income which has a impact on consumption. So C0 could be consumer sentiment, consumer confidence, wealth effect, the interest rates, and a host of factors, tastes, preferences, all those things which we are not directly or explicitly modeling in our consumption function are captured in C0. I is I0 minus FR. Here I0 is capturing investor confidence, investor sentiment, maybe GDP, which also is a determinant of investment, could be wealth, and many other factors which are not explicitly modeled in the investment function is captured in I0. So all the I0 captures all the factors which have a bearing on investment, but which is other than interest rate. Okay, and this is a very convenient framework. As we proceed we will see, but before we do that, let us try to discuss a bit about the LM curve. LM curve is derived while satisfying the condition of money market equilibrium. And when we say the money market is in equilibrium, the money market is in equilibrium when the money supply in the economy is equal to money demand. And money supply, we are saying uh, that money supply is decided by the central bank. And while discussing money supply, you would recall we had discussed about the money multiplier. And so the total money supply in the economy is money multiplier times the base money, and the central bank is able to alter the base money, and depending on the money multiplier, the money supply in the economy would be determined. And let we had said m is equal to small m into b, where m was where small m was 1 plus cr by cr plus rr, where cr was the currency deposit ratio and rr was the reserve deposit ratio. So if m we assume to be stable in the short run, then the central bank, by influencing the base money, can decide the money supply. So if we assume that the money multiplier is stable, we can infer, or we can draw the inference that the money supply is completely under the control of the central bank. Let money supply be M bar. But we are not considering the nominal money stock. We will consider the real money supply, or the real money balances. Now the real money supply is money supply expressed in terms of goods. Suppose you have some amount of money, maybe 500 rupees, and if you want to buy, suppose, a markers, and price of a marker is say 25 rupees, then the real money that is with you, I can tell that the real money with you is equivalent to 20 markers, because 500 by 25, it is 20. So when the money is expressed in terms of goods it can buy, we are considering the real money supply. So if M bar is the nominal money stock, and if price level that is prevailing in the economy is a P bar, then M bar by P bar is the real money balances. Okay, real money balances, or the stock of money in real terms. And P star is the P bar is nothing but the CPI, and which is given at a particular point in time. Let it be P bar, and we are assuming that this is sticky, or this is not changing in the short run. Now as far as the demand for money is concerned, there are, so we want money supply is equal to money demand, and money supply, we know money supply is equal to M bar by P bar. Now we want to see MD, the demand for money, or demand for real money balances. The demand for real money balances depends on, or is composed of, two components. One is the demand for money for transaction purposes, and the demand for money for non-transaction purposes. And the real demand for money for transaction purposes is a function of income, whereas the real demand for money for non-transaction purposes is a function of interest rate. And but how do they depend on income and interest rate? The transaction demand for money is telling a particular proportion of your income that you are keeping with you to carry out day-to-day transactions. And for the economy as a whole, we are saying what percentage of the GDP people are keeping with them to carry out their day-to-day transactions, or are keeping some money for emergency purposes or for precautionary purposes. The non-transaction demand for money is depicting that demand for money which is depending on interest rates. Now, the non-transaction demand for money can be understood if we consider that suppose consider two different scenarios. Suppose banks are offering 2% interest rate, and in another situation banks are offering 6% interest rate. Now, in which case you would like to keep more cash with you as compared to the alternative of keeping the money with the banks. Now, people would not like, because when the banks are giving a higher rate of return, the opportunity cost of holding cash with you is very high, because you are foregoing a 6% return. But when the interest offered by the banks is only 2%, perhaps people would not mind keeping more cash with them, because they would like to be relieved, or they would not like to take the hassle of dealing with a financial institution when the return is too low. So if I represent the interest rate that is prevailing in the economy, and this is my non-transaction demand for money, the non-transaction demand for money will be inversely related to interest rate. Okay, so this is say 2% and this is 6%. So when the demand for money, when the interest rate is only 2%, people don't mind keeping a lot of cash with them. But as the interest rate offered by banks increase, people find that the opportunity cost of holding cash is very high, and they would prefer to keep the money with the banks. Now, the transaction demand for money, we can also put it as KY. K is that fraction of GDP which people want to keep in the form of cash, and FR I can, because it is in, because the non-transaction demand for money is inversely depending on interest rate, I can put it as minus HR. What it tells is, as interest rate goes up, the non-transaction demand for money goes down. So total, if I say my total demand for money, that depends partly on GDP and partly on interest rate. And if I have to express it in a functional form, my total demand for money is KY minus HR. So if the money supply will be equal to money demand at equilibrium, I will get MS is equal to MD, which other words means M bar by P bar is equal to KY minus HR. If this other words will tell me HR is equal to minus M bar by P bar plus KY, which other words tells me R is equal to 1 by H minus 1 by H M bar by P bar plus K by H Y. Okay, so if I have to depict the LM curve, while which is representing a combination of R and Y, so that the money supply is equal to money demand condition is met, I am getting a curve with a negative intercept of minus 1 by H M by P. Okay, and with a slope of K by H, this is a positive slope, and this is my LM curve. So the LM curve is so drawn that it depicts different combinations of interest rate and GDP, so that the money market is in equilibrium. and the money market equilibrium was captured through MS is equal to MD, and MS was M bar by P bar, and MD had two components, KY minus HR. Okay, now this we have drawn the LM curve algebraically. Now I can also draw the LM curve from a different method. Let's try to do that. Now what I will do, I will derive the LM curve using the liquidity preference theory. I have said that money supply is equal to, so we are deriving the LM curve. Money supply is equal to M bar by P bar. So what we will do, MD, which was equal to MT plus MNT, which was a function of income, and this was a function of interest rate, income positively, interest rate negatively. Let us try to draw the LM curve while satisfying MS is equal to MD. Okay, here I will draw the the interest rate and the MD and MS here. So my money supply curve, which is M bar by P bar, is given, and it is decided by the central bank, as we have already discussed. And this is my demand for money, which is partly depending on income and partly on interest rate, and here interest rate is shown explicitly. So I am representing income from outside the model. Say income level was Y1, and here I am representing R. When income level was Y1, the demand for money, taking into account interest rate and income level of Y1, was, say, this. Okay, this was MD1 when income level was Y1. So MD and MS was equal when I had the interest rate at, say, R1. Now suppose income level goes up. When income level goes up, the interest rates, we are saying nothing happens to them. Interest rate is an outcome variable. So when income changes, the transaction demand for money, which is positively depending on interest rate, that goes up. So when the transaction demand for money goes up, so at each interest rate now more money is demanded. So that means at interest rate R1 more money is demanded, at interest rate R2 more money is demanded. Okay, so if I join, what I will get, this will be my MD2, which is a function of R and Y2, because income level has gone up. At each interest rate now more money is demanded. Which cat component of money? The transaction demand for money. So money supply remaining same, I will get my new equilibrium interest rate as R2, and R2 is corresponding to which level of income? To a income level of Y2. So I had this as one point and this is another point, and if I join, I get a upward sloping LM curve. Now this LM curve has been so drawn that it depicts different combination of interest rate and GDP, so that the money market is in equilibrium, where I am explicitly showing the supply of money and is equal to the demand for money. And now suppose everything else remaining same, suppose we want to show what happens to the system when money supply is changing in the system. I want to show what happens when money supply in the economy increases. When money supply in the economy increases, what I am saying, that suppose the supply of money was initially m bar m m1 bar by say p1 bar, okay, and the demand for money was md r y, and I was getting r1, and suppose this was y1. So r1 y1 was 1 point, and if we are saying income level goes up, if income level goes up, the demand for money also goes up, okay, and it becomes md r y2. So this causes the interest rate to go up to r2. So I am getting r2 and y2 as another combination, and when I join the two, I get the LM curve. Now we are saying, suppose money supply is increasing in the economy and price level is not changing, then that leads us to a situation of m1 bar becomes m2 bar by p1. So at the old, um, what is happening? This is my ms and md. This is my interest rate. This was interest rate. This is GDP. So what I am saying is the same income level y1. So I am saying income level, that means I am still on mdry1. If my um, if my money supply goes up, when the interest rate was say r1, okay, when interest rate was suppose r1, which was corresponding to the money demand curve mdry1 and money supply m1 bar by p1. Now suppose the at the old money demand curve, suppose money supply increases, so the new interest rate that is consistent with the old income level, because income level has not changed. What has changed is the money supply. So what I am saying now, in R1, um, inst instead of interest rate being R1, when income level is Y1, the interest rate will be R3 when income level is Y1, okay, and likewise the if when income level is Y2, the interest rate which was R2 will now be what? Now be say R4, okay, it will be R4. So that means y1 and y2 now correspond to interest rates r3 and r4 because money supply has increased. Now if I join then two new interest rates corresponding to the old GDP levels of y1 and y2, I get the LM curve LM1, which is a rightward shift of the LM curve. We can also show that if money supply reduces, this LM curve will shift to the left. Okay, this is LM curve shift. Okay, we can draw the LM curve using the fourfold quadrant also, and how that will look like. Let us have a look at that. The LM curve will be derived when money supply will be equal to money demand, and that I will represent using the fourfold quadrant. Okay, in the first quadrant I am depicting the non-transaction demand for money, which is a inverse function of interest rate, and here I am representing the non-transaction demand for money and here the transaction demand for money, and both are equal to the M bar by P bar, which is the money supply. And if I join the two, what I will get? This line will tell me different combination of MT and MNT, so that MT plus MNT is so that it is equal to MS, which is equal to M bar by P bar. Okay, so if I am at this point, what I am getting? My non-transaction demand for money is making the total money supply. The transaction demand for money is 0. Here the transaction demand for money is the entire money supply, and the non-transaction demand for money here is 0. And here I will represent, suppose the proportion MT is equal to KY. Okay, so this is, here I am putting MT and this is Y. So, and here I will derive the LM curve. This is R and Y. Let initially interest rate be R1. When interest rate was R1, MNT was MNT1, and which is represented here MNT1. Now if non-transaction demand for money is MNT1, what will be the transaction demand for money, so that money demand is equal to money supply? It will be MT1. So MT1 plus MNT1 is equal to M bar by P bar. Now what is the level of income which correspond to this level of MT1? This is Y1. Okay, so I am representing R1 and Y1 as one point where money demand is equal to money supply. Now suppose the interest rate falls. If interest rate falls, what will happen? The non-transaction demand for money will go up to MNT2. So if non-transaction demand for money is MNT2, my transaction demand for money will be, this is MNT2, this will be MT2. Now this lower transaction demand for money must correspond to a relatively lower level of GDP. Okay, and if I try to plot the R2 with the new consistent level of GDP, which is Y2, I will get another point on the LM curve. If I join, I will get the LM curve. So what we have done, we started with the non-transaction demand for money, which is a inverse function of interest rate. Here in the second quadrant, I have depicted the equality between money demand and money supply. So the money market equilibrium condition is depicted in quadrant 2, and in the third quadrant I am representing the transaction demand for money, which is some specific proportion of income. Okay, and in the fourth quadrant I am representing the derivation of the LM curve. So when initially interest rate was R1, it was giving rise to a non-transaction demand for money M1NT. The transaction demand for money, which would have made the total demand for money equal to money supply, is MT1. This MT1 is corresponding to a higher to a level of GDP Y1. So I am plotting R1 and Y1 as one point. And if I am now I am considering, if interest rate falls from R1 to R2, the non-transaction demand for money goes up, and this becomes now MNT2. So This will correspond to a transaction demand for money MT2, so that money demand and money supply equality is maintained. Now this lower level of MT2 will correspond to a lower level of GDP, because transaction demand for money is some specific proportion of the GDP. So if I'm plotting the lower interest rate with the lower level of GDP, I get another point, and if I join, I am getting the LM curve.